Okay, everyone, I'm going to do my best to explain dimensional analysis as a video you can reference to help you work through your math in this class. So, we're going to start with the little cheat sheet steps that I came up with earlier, which I think we talked about. Starting with, and I cannot state clearly enough, please do all these things. When you start doing stuff in your head, or when you're going to skip things, or go, I don't feel like taking the time to cross it off, that's when students make mistakes. So please use these steps. So you're going to start with number one. Write the units that you need in the answer on the far right side of your paper. So you have to figure out what the question is asking you first. Many times students get the problem wrong, not because they did the math wrong, but because they answered the wrong question. So write the units on the far right side of your paper, and then you're going to refer back to those later to make sure that your answer is in those units. And then these next two steps, I don't know how much it really matters what order these are in. It's in theory, it says we're supposed to start with the supply. That means the amount that you have on hand. Words that are cues to that are things like you may have a 500 milligrams vial with 2 mils of liquid in it on the unit, or you have 50 milligram tablets on the unit, something that's telling you what you have on hand. Next is looking at what the doctor actually ordered. That would obviously be important. And then you set up your problems so that you make sure you get the correct units in the numerator and the correct units in the denominator. This is the other mistake I see students make. Let's say the answer needs to be in milliliters per dose. And the information you have, the supply on hand, is in milligrams per milliliters. And so if you don't flip that and make sure that you put the milliliters on the top and the milligrams on the bottom, you're going to get the wrong answer. You're going to have the wrong units on the top or the bottom. So it will never be the right math. So make sure that you're looking and putting it the right thing on top and the right thing on the bottom so that your units end up in the right location. And then step 5, do any conversions that you need. 6, cross off all the units and make sure you do this and that every single thing crosses out except what you need in the answer. And I would also circle the things that are left to make sure that everything else is canceled out. Then you do the math, meaning you just use your calculator and you multiply the stuff across in the numerator, and then you divide it by the stuff you multiplied across in the denominator. And then you double check your answer and make sure that it is the correct units that you wrote down in step 1. So let's do a sample problem, okay? So let's say this. We've got that the doctor ordered gentamicin, an antibiotic, and the order says it's 2.5 milligrams per kilogram intravenously every 8 hours for an infection. The vial we have of the medication is labeled 40 milligrams per mil. Ooh, I didn't do capital T here, everybody. The child patient weighs 60 pounds. How many mils will you give? Okay, now let's apply the steps. And then I have this important thing listed right here. It says, unless it states how many milligrams will you give per day, unless that's what they're looking for, you can always assume that when they ask how many mils will you give, you can assume they are meaning or referring to how many mils per dose. So it's really important. What are they asking? How many mils you give? So how many mils per dose? So step 1, I'm going to write out the units in the answer on the far right side of my paper. Here I have it, mils per dose, right? Step 2, I'm going to start with the supply. And it says up here, I have 40 milligrams per mil. So I'm going to write that down, 40 milligrams per mil. So I just know what I have. Step 3, I'm going to look at what the doctor ordered. And it says up here, the doctor ordered 2.5 milligrams per kilogram. And we can assume that means per dose because this is each dose. And then the doctor says I have to have a dose every 8 hours. So we can write 2.5 milligrams per kilogram per dose. And then I wrote, we don't care that it's every 8 hours because we are only calculating mils per dose, not mils per day. If it was mils per day, we'd care. So we're going to write 2.5 milligrams per kilogram per dose. Both of these things are in the denominator. You'll see that further on. Step 4 says set up the problem so you can make sure you get the correct units in the numerator, which means on the top, and the correct units in the denominator in the bottom. And I give you an example here of what people accidentally do for a mistake sometimes, but let's look at the right way. So I wrote down Since we know we need to have milliliters on the top, then when I take the amount that we got, the supply that we started with this 40 milligrams per mil, I better flip it upside down and have the mils on the top and the milligrams on the bottom. Otherwise, I'm never going to be able to get milliliters on the top if I don't start that way. So that's the way I'm going to set up the problem. 1 mil over 40 milligrams is the supply. And then we have that the doctor ordered 2.5 milligrams per kilogram per dose. The other thing you really pay attention to is remember all the units you don't need have to cross out. So you have to be able to cross multiply and get rid of those units. So if you're like, well, I don't know how to set up the doctor's orders, you do, because you have to get rid of milligrams. So the only way to set up the doctor's order would be to have milligrams on the top and this stuff on the bottom, so that this and this can cross off eventually. Okay? Let's move down to step 5. It says, make any conversions that we need. Well, we know we've got the supply, we've got the doctor's order, we have that. But they also said up here, if we go back up, it said that the order says it's 2.5 milligrams per kilogram. So that means this medication is based on a patient's weight. That usually happens when a medication is for a pediatric patient. And we're given the fact that there's 60 pounds. So for a couple reasons, it would cue us that there's more work we have to do. And I'll tell you why. Because if we just stuck with these two things, we would still have kilograms in the answer. And we don't want kilograms in the answer. We want milliliters per dose, right? So somehow we have to get rid of those kilograms. And we also have to consider the kid's weight. So we're going to go down. Sorry if I'm giving you a seizure by going up and down. It's a small price to pay to learn dimensional analysis. Okay, so we've got the supply, we've got the order, and then we need to start looking at what do I need to get rid of? So what kind of conversions do I need to do? And then I need to consider the patient's weight in this situation to make sure that we can get, because we have to get rid of all these kinds of units. So if I have kilograms down here, we know that we have the kid's weight in pounds. So we're going to get rid of kilograms, we're going to go 1 kilogram equals 2.2 pounds. And then we're going to include the patient's weight, 60 pounds. And let's see how that works when we cancel off all the units. So it says step 6, cancel them all off. It looks like milligrams and milligrams will cancel out, right? Kilograms and kilograms will cancel out. Pounds and pounds will cancel out. Oh my, look what we're left with. Milliliters per dose. Now we just multiply all the way across and we get 150. We multiply all the way across the bottom and we get 88. And we use our calculator to say 150 divided by 88 is 1.7. And we know that the units we're left with are mils per dose. And then it says double check your answer that you wrote down on step 1 to make sure that your answer is in the correct units. I have 1.7 mils per dose. Up here in step 1, I wrote mils per dose. So we know it has to be right. Okay? Fantastic. Now I'm going to take one more step and we're going to talk about reconstitution problems a little bit. So we got through all of that, and you can apply this to every single question you ever have in this class on dimensional analysis. If you understand this, you can do dimensional analysis. So you're in good shape. Now let's look at the other information I gave. There are things called reconstitution problems. It'd be easier for me to show you, and I will do this in the classroom. What that means is I'm taking a vial of powdered medication and I'm taking a syringe of saline or a bag of saline and I'm adding liquid to that vial of powdered medication and I'm rolling it in my hands essentially and dissolving it. It's honestly no different than taking a packet of Kool-Aid, reading on the thing, 1 packet for, I don't know, half a gallon of Kool-Aid. And then you dump it in a half a gallon of water and it dissolves. That's all it means, reconstitution. It's no harder than Kool-Aid, okay? So that's all we're doing, only we're doing it with medication that if we screw it up, it could be real bad. So we take it very seriously. All right, so there are 2 types of problems you might see. Number 1, this is the old school way. You might not be provided a quote unquote given concentration. If that's the case, you have to calculate the concentration yourself. And you'll do that because you'll have two important pieces of information. You'll have the milligrams of medication, and that'll be like the vial of powdered medication. And you'll have the milliliters of diluent supplied. All that really means is it's telling you how much saline or sterile water to dissolve the powdered medication in. I'm going to give you an example of that problem in a couple of minutes. And then the other one, or a couple seconds actually, the other option that you might see is that you might be already given or provided a given concentration. Oh, piece of cake. They already told you. The tricky thing is if you are provided a given concentration, those problems always have medication labels on them. And where students get tripped up is they feel like they need to use every number on the label. And that will completely mess with you. So just know, if you are provided a given concentration, and I'll show you what that means below, that's the only thing you pay attention to as far as your quote unquote supply that you have on hand, okay? Don't be tricked by looking at anything else on the label. So let's start with a problem that does not give us the given concentration. That means we need to figure it out, okay? So the doctor orders 250 milligrams of methylprednisolone sodium succinate to be administered intramuscularly, or IM, 3 times a day. So they're getting an injection of 250 milligrams of this medication. Based on the amounts applied below, how many mils will be administered per day? So the other thing I recommend is highlighting or underlining the stuff in the problem that you think you might need to solve the problem. And that's what I did here. And here's the medication label, what it says, okay? So I'm sorry that my stylus wasn't working, so I had to try and do this with my finger. But this is what the label says. You have 500 milligrams of this powdered medication, methylprednisolone sodium succinate, also known as Solu-Medrol. And it says here that you need to reconstitute it. That means mix the Kool-Aid powder with the water, right? Mix the medicine with the saline or sterile water or whatever they're telling you to mix it with. Here they're telling us that it is bacteriostatic water. So you are going to mix it with, I actually should have underlined this right here. This is really the 8 milliliters of bacteriostatic water, okay? So we have 500 milligrams and we have 8 mils. And based on that, we know that we can start by applying, well, let's just walk through the steps. That's what's going to be our supplied amount. So step 1, we're going to write the units in the answer on the far right. I told you above, I had highlighted it. They want to know milliliters per day. Pay close attention. Didn't say per dose, it said per day, right? So we're going to need to know how many doses the person gets per day. Let's go back up there and look really quick. It says up here 3 times a day, okay? So 250 milligrams per dose, 3 times a day. So that's important. We're going to start with the supply. We already looked at the label. I said that it shows 2 things, 500 milligrams, and that it's dissolved or diluted or reconstituted in 8 milliliters of saline. Next, we're going to look at what the doctor ordered. Let's go back up there and see. Oh, crap. Julie, darn it. 250. This is why you double check your math. Let's pray I did the rest of it correctly. 250 milligrams per dose. And it's important to note that there are 3 doses per day because the answer needs to be per day. So both of these things are important. Next, we're going to, oh, God dang it, guys. All right, you're just going to see that I am a flawed human being, and we're just going to work through this, okay? Okay, set up the problem so you get the correct units in the numerator and the correct units in the denominator. Remember, we need mils per day, so we better, with this supply, put the mils on the top and the milligrams on the bottom. For the doctor's order, because we want these things to cross out, we're going to put the milligrams on the top and the dose on the bottom. But we don't want our answers in mils per dose, we want it in mils per day. So somehow, we also have to make sure we get to how many doses per day, and we found out it was 3, so we'll put 3 doses per day. Make any conversions that are needed. I need to go back up here just to triple check. It did say 250. It did. Okay. Make any conversions that are required. I think we pretty much have everything we need right there. We're going to cross off all the units that we need to have canceled out. So we did milligrams and milligrams, doses and doses, And what we're left with is mils per day. Now, we're going to do the math calculations, and now I have to figure this out. How fun is this in real time, guys? Okay, and I'm going to do this. I am going to say 8 times 250 times 3 is 6,000. Okay, and we still have 500 on the bottom. Divided by 500 is 12 mils per day. And it says I'm going to double check that my answer is in the units that I wrote down during step 1. 12 mils per day. So if your brain works firing on all cylinders and you're transcribing the correct information into the problem, you should get the correct answer there. So these are the harder of, well, I shouldn't say the harder of the two. You have to do a little bit more work if you're not given a concentration already, but they're less tricky, okay? So that one's done. Now let's move down to what would happen. I mean, look at this, amazing. After I double checked my work, I should add that caveat. Sample problem when you are given a given concentration. And here's what I said. If you're provided a given concentration, use it. Ignore the milligrams listed on the label or the milliliters of the amount that you need to dissolve it in. Don't be tricked by that stuff. So let's take a look at this. The doctor ordered 250 milligrams of azithromycin intramuscularly twice a day. How many milligrams will the nurse administer in a dose? And then it says the amount supplied is listed on the medication label today. Notice, or below, notice I did not highlight twice a day. The reason I didn't is because what they're asking for is how many milligrams is he or she going to give in a dose. So I don't care how many doses there are in a day. It's just going to confuse me to have that information listed. So let's take a look here at what the label says. We know the order's 250 milligrams a dose. And this vial, or this label for this medication for azithromycin, also called Zithromax, says that when you mix the powder with the specific amount of water, you're going to get a concentration of 100 milligrams per mil. Now look at how screwed up you're going to be if you start accounting for all these other things. If they give you the concentration, ignore this. Ignore the amount of water needed. Ignore the label on the medication. Only use the reconstituted concentration. They're already doing the work for you. I don't even want to go down a rabbit hole as to, Julie, shouldn't it always work out? I'm just going to say we can talk about that in person if you have questions. But just know you have to look at the concentration and forget the rest of it. Don't do anything with 500 milligrams. Don't do anything with 4.8 mils, okay? So let's move on. And look at how tempting it is. It's very tempting, guys. So be gentle with yourselves. It's very tempting, but they already did the work for you. So you're going to write out the answer you need in the far right, the units. We had read it was mils per dose. You're going to start with the supply on hand. That's the concentration they gave you already, okay? So look up here at the label. I said focus right here. It says 100 milligrams per mil. So we're going to write 100 milligrams per mil. Step 3, look at what the doctor ordered. Oh God, please have it be 250. Okay, thank you. I should have chosen some different numbers. The doctor ordered 250 milligrams per dose. Don't worry about the number of doses for the day because they're not asking us for the day. So ignore that. You might even want to cross it off in the question so it doesn't confuse you. And then set up your problem so you make sure you get the correct units in the numerator and the correct units in the denominator. By this time, you guys should be masters of doing that, right? We know we need mils per dose. So again, we're going to make sure that our supply is written with milligrams on the bottom, milliliters on the top. We took this number here to get that. We got the MD order from up here and put that here. Step 5, make any conversions you need to. We don't even have to make any conversions. There's like nothing more we have to do. Cancel off the stuff of all the units that cross out and see what we're left with. So with the mg and mg cross off, we have milliliters per dose. We do the math, go across 250, and on the bottom 100, 250 divided by 100 is 2.5 mils per dose. Double check. Yep, we wanted mils per dose. I mean, seriously, this is what you're going to say about yourself. I cannot believe how smart I am. This is just absolutely crazy. So I am hoping these were not like the, well, they are what they are. These problems are very pertinent. And even if you get the weight-based problems are probably the hardest with the pediatric and if they talk about per day and per dose, I mean, that can trip people up and there could be a lot of things that you need to convert and cross over depending on what you're given. But always remember, if you follow these steps, it does not care. It does not matter. You will get the right answer if you walk through this process. So I am really hoping that this helps, guys. I will post this document in Canvas as well. And feel free to let me know if you have questions and look at the schedule, see when I'm in the lab, come and meet me there. I am happy to help. So have a great night.